This tutorial is more about factoring, factoring x squared plus bx plus c, but I'm going to start with a couple of examples of expanding to show you how these are called algebra tiles over here. They're meant to represent the quantities x, negative x, and this are the same. They're just oriented differently. This one goes across this way. This is a rectangle that's 1 unit by x unit, so 1 times x is x. These are 1 or negative 1. See, this is supposed to be a square. It's 1 unit by 1 unit. 1 times 1 is 1. This is 1 unit by negative 1 unit, so that's a negative 1. So that's a positive x, that's a positive x. This one here is a negative x, just like this one. Just this one goes up and down, this one goes across. And this is a positive x squared here. This is a negative x squared. Okay, so when we need those. So to expand x plus 1 times x plus 3, and I'm going to show how to do this using the algebra tiles, and then also how to do this algebraically and draw connections between the two of them. So in order to multiply x plus 1 by x plus 3, I'm going to create a rectangle that has an x plus 1 across one dimension. So this is my x plus 1 here. And then the other dimension is going to be x plus 3. So that's why I need some more horizontal, some vertical. This is going to be an x and then plus 3. So that would be x plus 1, x plus 2, and x plus 3. So this is my x plus 1 dimension, and this would be my x plus 3 dimension. So I'm going to fill in this to make a rectangle that this completely fills. So to fill in this space right here, I need one of these x squareds. To fill in this space here, I need one of the x's that's vertical, up and down. And then there's going to be 3 more x's here, so let's do that, fill that in. And then to complete the rectangle, I need 3 of those little squares. I need 3 of these ones. So the algebra tiles is based on multiplying 2 binomials, or actually it could be, I guess, it was a monomial times a binomial or a binomial times a trinomial, 2 things, is the same as finding the area of a rectangle. So if we think of one of these as a length, one of these as a width, so I could think this is the width of the rectangle, this is the length, or vice versa, it wouldn't matter. And so I'm really just finding the area of the rectangle. So I'm going to write out what these products are. So I'm going to start right here. See, this is an x squared. So I have an x squared. Oops. An x squared. And then I have these 3 x's here. So there's plus 3x. And I have this one other x here. And then there's the 3 here. And these are like terms. 3x and 1x is 4x. Even though they're oriented differently, they're all x's, 1x's. So altogether there's 4x. So the simplified version of this would be x squared plus 4x plus 3. So that's how we could use the algebra tiles to find that product. Algebraically, what I could do is this. If I multiply this x by this x, it gives me this x squared. If I multiply this x by this 3, it gives me this 3x. And then this 1 times this x algebraically gives me that x. And then 1 times 3 gives me the 3 in the end. And if you've ever heard of it, that's actually FOIL. So f is the product of the first 2 terms. O is the product of the outer terms, the ones that are the furthest apart from one another. I is the product of the inner terms, the 2 that are closest to one another. And L stands for last, the product of the last term in this one and the last term in this one. So that's how algebraically you could do it if you weren't using algebra tiles. Now, one more example here, the x plus 4 times x minus 2. So I want to make sure I have enough room. Oh, yeah. So x plus 4, so I need an x, let's start up here, plus 4. So I need 4 ones across the top there after my x to make, so that would be x plus 2, x plus 3, x plus 4. And the other dimension here is x take away 2. So it's a positive x there. Now take away 2, I need 2 of these minuses. And so we fill this in. You see, this right here is a positive x times a positive x, so it would be a positive x squared. I don't need the negative x squared actually for any of these. See, these would all be positive x's because they're a positive 1 times a positive x in the other dimension, so I'd fill those all in with these ones here. Now, these ones down here, you see, this is x across here, and this is negative 1. So negative 1 times x would be a negative x. So I'm going to fill this in, and the one below it too, with a negative x, because it's the product of a positive and a negative. And then each of these little squares here are 1 by negative 1. See, that dimension there would be negative 1. So I need negative 1s for all of these. After I finish this multiplying, I'm going to draw the comparison to factoring, so we'll get into the factoring shortly here. I've been just doing expanding so far. Okay, so let's write out what we have here. So we have this x squared. So x squared. We have these two negative x's here, so that would be minus 2 of those, minus 2 x's. Plus there's 1, 2, 3, 4 x's there. And then there's 8 of these negative 1s, so that would be a minus 8 on the end. And again, like the above, these are the like terms, negative 2x and 4x. See, it's kind of like, do I have a red here? Red's good to cancel things out. It's kind of like this one and this one add to 0, so they're gone. And then this negative 1x with another one, doesn't matter which one, add to 0. So I'm really just left with 2x's. See, negative 2x and 4x add to positive 2x. So my final answer is x squared plus 2x minus 8. And I could algebraically do this. So here's my FOIL again. X times x is this x squared. X times negative 2 is the negative 2x. 4 times x is the 4x. And 4 times the negative 2 gives me negative 8. And again, I collect my like terms. Now, factoring. So let's say instead you were given the expression x squared plus 4x plus 3 and you're asked to factor it. Factor it means to put it back in this form. What two binomials would multiply together to give me x squared plus 4x plus 3? So the way we can do this using algebra tiles is to say, well, how would we arrange an x squared, two 4x's, and a 3 to make a full completed rectangle or square? Okay, in some cases you might find they're squares. See, there has to be 3 down here. I can't, for example, let's say I get rid of this one. I'm going to stick it over here for a moment and used one of these. Okay, so here's my x squared, 4 x's, so there's 2 here and 2 here, and I got 3 1s. Well, see, I can't quite complete the rectangle because I'm missing some here. That's why I can't have another vertical x here. I need to orient them this way. in order to make a full completed rectangle. And then from the rectangle, my factors would be x plus 3 and x plus 1. If I was instead trying to factor, let's see here. Let's get rid of this guy. Delete him. So let's move this. I'm just going to sort of move this out of the way a bit. So let's say we had x squared plus 2x minus 8, and we wanted to factor it using the algebra tiles. So I had this x squared. Maybe we'll scroll down a little bit. 2x's. And well, originally I wouldn't really know, do I have, one like this and one horizontal? You kind of play around with it around it. And then -8, so I need 8 of these. 5, 6, 7, 8. There's my 8. Now, you see, I've got all these, I can't stack them like this because there's no even number of those exactly the same as an x squared, so they have to be like down the corner here. So, well, 8, I need to be able to make it into a rectangle, so, it can't be, I can't have it 3 one way and, 3 another because it doesn't quite make the rectangle. So I have to somehow do 4 by 2. See, 4 times 2 is 8, so you see, there's my, you kind of think I'm cheating because I'm looking up here. There's my, I've got a full rectangle with the little ones, the little negative ones. But you see, I've got 2x here, but this is all blank. So, how do I fix it so that it's a full completed rectangle and I can see the 2 dimensions that are x plus 4 and x minus 2. And what we can do is, you see, I can swap these out for any horizontal or vertical ones. So what we're going to do is every time I do this, I'm going to introduce a pair of these. Okay. So I still got my 2x's here. I'm not forgetting about those. But you see, when I bring in a negative x and a positive x, those are actually opposites. They add to 0. So between those two and these, it still adds to 2x because that actually is 0 there. So if I add in another one with one of these, see, that's actually, I just added another 0 pair because they're opposites. Now I need these two to be going vertical. So I'm going to, instead of putting those there, I'm going to put these here. And so now I have the fully completed rectangle. This total value is x squared plus 2x minus 8 because you see this one, this one, this one, and this one, that all adds to 0, and I just had the 2x's, and there's my -8. And so I could read from this now that this is x plus 4 across the top, and this would be x minus 2 in this dimension, minus the 2. So what you're doing to factor using the rectangles is you're arranging them so that you can make a fully completed square and see the length and width, the 2 dimensions, and those are the factors. So let's take a look at, I'm going to erase a whole bunch of this. I'm going to bring in some of these other factoring examples that I have up here. I don't need my foil anymore either. There we go. Okay, so x squared plus 5x plus 6. So I had this x squared. And, the 5x's, how many of these do I need? Do I need like 4 of these? And they're all positives, and 1 of these. So let's try that. Oh, I need six ones. So I need 1, 2, 3, 4, 5, 6. So let's try to make a rectangle out of this. So, and I see fairly quickly that, if I put these 4 here, oh, I got 2 left. I can't, I can put that there. There's a full rectangle, but you see, I need to have included those. So that's not working for me. So well, let's do this instead. Okay, so I want to make a rectangle of these 6. So I need to arrange them in a fully completed rectangle. So if I did this, and so instead we can swap that out. So let's get rid of that guy and put one of these in instead. There we go. So 1, 2, 3, 4, 5, 6. So there's my 5x. There's the 6 here. There's my 6 and the x squared. So this dimension here would be x plus 1, 2. So this would be x plus 2. And this would be x plus 1, 2, 3. So this would be x plus 3 here. So those are the factors of x squared plus 5x plus 6. And it doesn't matter which you write first. Now, some generalizations here before we get into another example. This is 6 here. Notice that this is a rectangle here that's 2 by 3. That 2 and that 3, notice they multiply to give you the 6 on the end here. So the numbers on the end, their product is always going to be this product here. This 5x comes from 2x's and 3x's. Okay? You see, if we were thinking of some of the FOIL here, see that product is 2x. This product is 5x, so that, sorry, 3x. 3x. That's pretty awful. Let's get rid of that. 3x. And so that's where the 5x comes from. Notice that 2 and 3, I just said they multiply to 6. They also add to 5. So this number here is actually the sum of the two numbers in the end. And this guy here is the product. So let's try another one here. Let's bring this one over. You may think of this looks kind of familiar. This is one of the products from before. So let's say I was starting with this and I want to factor. So here's my x squared, 4x's. So, how do I put my 4x's? Do I do like 2 there and 2 there? We'll see, because we can always swap out. Plus 3, so we need 3 of these 1s here. Oh, I need 3. That's too many. Get rid of that one. So that's my problem here, arranging it like this. See, I want 3 in the end, but so the only way to do the 3 is like this. So I need to get rid of that guy and bring in one of these. So I have the 4x's. 1, 2, 3, 4. I have the 3 here. So, okay, so here's the factors. So this would be x plus 3 across the top and x plus 1 on the side. And again, it doesn't matter which you write first. Okay, so see, they both start with x's because that's an x squared. You see, you can always check any factoring by expanding it out. X times x is x squared. Notice that this 3 and this 1 multiply to give you 3, just like the product up here, they multiply to give 6, the 2 and 3. So 3 times 1 is 3, and 3 and 1 add to 4. You see this product right here, if we did part of the foiling, would be 3x. And this part here would be a 1x, and that together adds to the 4x. So that's that same property from up here seems to work. Now, we're kind of running out of space here a little bit, so let's get rid of some of this. And delete that. Take a look at one of these examples with the negatives. So we need an x squared. Okay, so there's an x squared. We need a negative x. So, I'll just grab that one. Maybe we actually need a vertical one. We'll see. And we need a -6 there. So let's grab 6 of these negatives. So right now, if I just had the one -x, I mean, I would have to do this. But the problem, if I strung them all along here, the problem is that, well, I don't have any x's up here. This whole part's blank. So, how do I arrange this? So there's 6 things. So you go this is a 1 by 6, but you see instead, I could go like this, okay, like that, or conversely, if you really want to, you could do this instead. Either of these works. So what I need to do is I need to fill in the rest here. Rearrange this a little bit better so it's more complete. Yeah, there we go. So I need to fill in pairs. You see, if I take and throw that there and that there, see, adding the 2 of those is actually adding 0. So these 3 x's, a -2x and an x, still add to -x, so that's fine. And then if I add in another pair, one here and one here, you see that's another pair that adds a 0. So those 3 negative x's and 2 positive x's still add to -1x. So that would mean that my factors here, see, this is x plus 2 across the top, and this would be x minus 3 here. Let's look and see if that product sum thing works again. X plus 2 x minus 3. So what do these two numbers multiply to? If we multiply those, they multiply to -6, the -6 on the end. What do they add to? If we add 2 and -3, you do get -1, the same -1 that's right there. So this is a strategy for factoring trinomials. In order to find these factors, see, it has to both start with x, because x and x are the only 2 things that multiply to give you x squared. Okay, so that's why there's an x here and x here, because those 2 things are the only 2 things that multiply to give you an x squared. The numbers on the end, like the 2 and the 3 here, they're 2 and 3 because 2 and 3 add to 5, that's the sum, and they multiply to 6. Okay, there's other products besides 2 and 3 of 6. For example, 1 and 6. Well, maybe 1 should go here and 6 should go here, but the problem with 1 and 6 is they don't add to 5. They add to 7. Like if there's a 7 here, then that would work. Down here for this one, if you didn't have, this whole algebra tile diagram here, in order to factor this, we need an x at the beginning and x at the beginning of each one. And we look for 2 numbers with a sum of that -1 beside the -x and the product of -6. And the only 2 numbers that do that are the 2 and -3. 2 and -3 add to -1, and 2 and -3 multiply to -6. Now we can use this idea, and I'm gonna take these 2 down here where I've got some more room, and we'll use this algebraic strategy. Maybe we'll do that one there and this one here. I'm not going to use algebra tiles for these. So in order to factor this, I'm looking for 2 binomials that if I were to multiply them, you can always check any factoring by multiplying, they multiply to give you that trinomial. So this has to start with an x, because it's x multiplied by x that gives you this x squared. And in order to find the 2 numbers that go here and here, I'm looking for 2 numbers with a sum of 3 and a product of -6. They multiply to give you -10. Thinking of the -6 in the last question. Well, so -10, what can we think of that are factors of 10? 10 and 1, I'll get into the negative in a second. 10 and 1, 5 and 2. You see, it multiplies to -10. So you could have the negative here, or it could be 10 and the 1 could be negative. See, the 5 could be negative and the 2 positive. Or the opposite could be true. It could be positive 5 and negative 2. And that's the only pairs of numbers that multiply negative 10. So you got to ask yourself, well, which of these add to 3? Those certainly don't. See, those two numbers add to negative 3. So it's the 5 and the negative 2 we need, because 5 and negative 2 add to positive 3. So plus 5 here, minus 2 here. And again, you can always check your factoring by expanding this out. So x times x gives you x squared. X times negative 2 is minus 2x. 5 times x is a 5x. 5 times negative 2 is negative 10. And if we collect the like terms, see negative 2x and 5x adds to that 3x in the middle. This guy right here. And we do have a minus 10 on the end. So it does factor like. Those are the correct factors. So we could put nice red check mark here. Last one here, number 5. So we're trying to factor this into two binomials. This has to start with an x here and an x here, because it's x that times x that gives you this x squared. The sum here would be 5. And the product would be positive 2. The two numbers we're looking for and the ends of these binomials would be positive 2. So let's write out all the numbers that multiply to positive 2. Well, let's see now. 2 and 1. 2 and 1 multiply to 2. Oh, I guess negative 2 and negative 1 also multiply to positive 2. That's also correct. So, but we're looking for pairs of numbers that add to this 5. See, 2 and 1 don't add to 5. Negative 2 and negative 1 also don't add to 5. So if this is an exhaustive list, if that's all the possible numbers, and it is, then multiply to positive 2, then this doesn't factor. It's not possible to factor. So sometimes it isn't possible to factor. So in that case, you would write something like can not factor. Because it's not that every single one can be factored into the product of two binomials. Okay, so that's why sometimes the questions will say factor and then comma if possible. And that's the end of the tutorial.